Guess who's back with the new Battle Mage GPU? Intel, you could read the box. This is the B580. It's the Intel Arc B. It's okay. Technically, this is Arc B series, codename Battle Mage. 12 gigabytes of GDDR6, 192 bits, PCIe Gen 4 interface, real-time ray tracing capabilities. There's a lot to like here for $250. Intel has made a lot of promises, a lot of very, very tall promises, and we're going to put it to the test. This GPU basically promises to give you a reasonable 1440p gaming experience, even with ray tracing, though you might need frame generation. This could enable gaming on a relatively inexpensive machine. You could be giving this as a gift or receiving this as a gift this holiday season for a reasonable gaming computer. This is going to redefine what $250 is, assuming that Intel can get the software right and make sure that the game support is top-notch and that all of the other stuff is in place there. That is a shockingly lightweight card. It's got flow-through cooling. It has a single 8-pin power interface, so it's very, very low power. It could upgrade an OEM system. Now this is a full Displayport 2.1 graphics card. Well, almost full. This DisplayPort output that has the line around it is the higher bitrate DisplayPort 2.1. Well, it's 13.5 UBHR, but for the specifications, like, okay, so you can do 8K or up to 4K 360 Hertz on the DisplayPort with the outline, and the other ones can just do 240 Hertz at 4K because the amount of bandwidth varies. That's technically allowed under DisplayPort 2.1, but the full fat DisplayPort 2.1 is like 20 gigabits per channel, and so you could get even higher frame rates. So there's different bit rates of DisplayPort 2.1, and not very many monitors on the market. There's 4K 360 Hertz. There might be like one OLED that can do 480 Hertz of 4K right now at the time that I'm making this video, but I digress. This is your 1440p card. This is the 580. It is the successor to the A580. This is the B580. This is not something you pair really with a 14900K or a 9800X3D or the highest end gaming CPU either. It's a $250 GPU. You put most of your money into the GPU and less money into the rest of the system for gaming oriented stuff. If you do lightweight gaming or occasional gaming or esports titles, this could make sense where you spend a little bit more on your CPU. You get, that higher end 12 core, 16 core, 24 core, whatever. And you need something that you can do some light gaming on. $250. That's a reasonable choice with 3 DisplayPort out plus the HDMI 2.1. Now that HDMI 2.1 that can do 4K, 120 Hertz, 240 Hertz, and beyond, because HDMI stuff. HDMI at those bit rates uses display stream compression, so it's not exactly an apples to apples comparison that we're talking about for bandwidth. But let's get to the gaming benchmarks, which we will benchmark with a higher end CPU because that makes sense for gaming benchmarks. But I also want to touch on some benchmarks for some other reasonable configs. 2 configs in particular. One with our Pixio 1440p OLED display, because OLED is the butter for your eyes option. There are also very affordable 1440p VA panels, such as the ASRock Phantom Gaming panels we've reviewed in the past. That would also make a good pairing with this GPU because, maybe you're not ready to run 4K. And that makes sense because $250 GPU. This GPU is designed to compete with $350 to $400 GPUs, but again, only cost $250, which is in line, a bit less if you take into account inflation, with the launch price of the A580. So the B580 brings, according to Intel's documentation, 25% to 33% more performance, plus ray tracing, reasonable ray tracing performance that Intel promises is significantly better than AMD. We'll put that to the test in just a minute, at the same price point. So let's see. Now, I mentioned unconventional build ideas with this card. Let's talk about that for a second. This system is based around a commodity inexpensive Minis Forum motherboard. It comes with a mobile CPU. Basically, this is a class of low-cost, typically low-cost, not always, motherboard that comes with a mobile CPU soldered to it. Sometimes they can come from AliExpress, they can come from other vendors. Minis Forum is one of the more reputable vendors, and even with that, you're not going to get as cohesive as an experience as you would from ASRock, MSI, Gigabyte, and Asus in terms of, you know, fully baked platform. But the system at times, like this kind of a platform, the AMD 8-core, I think the lowest price that I saw was $359. This is an Intel mobile i9 13th gen. The lowest it was, I think, was $399. But that's the motherboard and the processor and everything. And that is a really good deal for that level of performance. So you can do that very inexpensively and end up with a machine before the GPU that's on the order of $600–700. This is in a designer fractal case. You would not put it in a designer fractal case to save money. You would want most of your budget, again, to go to the GPU, or as much as possible. So a used OEM system could make sense. Like, you might be able to get an i7 or an i5 used system with a single 8-pin power connector, and that would work fine for the setup. The only reason I'm not out here recommending the ASRock Desk Meat is because this won't physically fit in the ASRock Desk Meat. That is a bare bones system, is what they used to be called, where you get everything except the processor, memory, and everything else. You gotta add your own processor to that. But there are ways. There are ways. While we're waiting on Halo Infinite to resolve some texture shenanigans, because, hey, the Intel drivers haven't had a history of being absolutely perfect this whole time. But they've gotten better, faster than any other gaming GPU in history. Let's talk about power management. So, a common thing that has happened from both Nvidia and AMD cards is if you're running a display that's capable of 120 Hz or even beyond, that Pixio display, man, that is really capable of some very high refresh rates. It dramatically increases the amount of power the card uses. Well, not this one. Total board power, as measured by me, is about 13.5 watts at 120 Hz running a single display, or about 7 watts running a single display at 60 Hz. And so if you are a casual gamer, and you're somebody like me that likes to have a bunch of very large high-resolution monitors, this card could make sense just because of the power savings alone. It's not adding heat to the rest of the system, and everything else runs exceptionally well. So that's pretty awesome that they've factored that in. And keep in mind, it's also only 8 PCI Express lanes, 8 PCI Express 4 lanes, and that comes with an inherent cost savings and power savings as well. And all of that is even before we take into advantage XeSS 2 and the upscaling technologies, and also sort of the full Monty. I don't really know how to explain it, but Intel is taking a tiered and complete approach with the drivers in terms of latency and reflex type. You know, the Nvidia reflex, like how quickly does it respond, even using some of Nvidia's technology to measure their own in-game latency. And it's like you can turn on Xe low latency mode, and it's a little too early for me to tell how good that stuff is, but I can tell you that the Xe upscaling technology is quite good. And so I was a little skeptical of, okay, if you have an older title, like say Borderlands 3, this is actually a reasonable experience even playing at 4K. Now, it's not 100 FPS, but you can generally maintain 60 FPS using those upscaling technologies. And the driver feels a lot more mature. Both, well, if you remember the way that the A770 launched, like it launched and it was kind of rough, and then like 2 months later they had a major driver refresh, and that really dramatically improved things. This is pretty good out of the box. Like, this was a genuinely fun gameplay experience, even turning on some of the more advanced frame generation and upscaling technologies. Now, frame generation and upscaling are two totally different technologies, but both of them, I think, have large software teams working on them, because this is an impressive level of polish. And again, Intel has come a very long way in very short order. It's interesting that these GPUs don't really directly challenge Nvidia performance per se, but objectively, I think with the ray tracing experience, it does actually sorta kinda. I mean, this is a $250 card, but it shows that ray tracing, which I think on Nvidia cards is basically treated as an afterthought unless you've got a 4090, is actually a reasonable experience on this GPU. It's shocking. I mean, even comparing ray tracing on something like the AMD 7600, which is also a little bit more expensive of a card, older, sure, but a little bit more expensive, the ray tracing in this is actually usable, whereas on the AMD side, generally I've said like the 7900 XTX and the 7900 XT, the highest end cards are the only ones that really give you a good ray tracing experience. This is not like an amazing ray tracing experience, but it's not terrible. It's pretty good for what it is. It shows a lot of promise. And I also like PresentMon and what Intel is doing there in terms of let's make the graphics pipeline a little bit better and a little bit more sane and lean on Microsoft to do certain things and certain other things. With the Vulkan interface, there's also really a lot more overlap in the driver stack between AMD and Intel than really anybody would probably be comfortable admitting. I mean, Intel has done a lot of software engineering, sure, don't get me wrong, but the approach with Vulkan and a lot of the design philosophy that AMD has given us, as opposed to keeping things more locked down, if you look at Team Green's philosophy, has enabled Intel to move as quickly as they have. I think. That's just my opinion, but I can point to very specific technical things in the driver stack and with Vulkan that make me think, yes. Not to say that I think AMD has made a strategic mistake. I think it's absolutely a necessary thing to do in this ecosystem, but for better or worse, because of this, Intel and AMD are a little bit frenemies when it comes to the driver stack and the ecosystem health and building something that's reasonable for developers when we're talking about an actual real gameplay experience. At the same time, Intel does have a lot of special sauce in their hardware when we look at what they've done for their shaders and what they've done for the caching and what they've done for the close coupling between the driver architecture and the silicon. Well, it has borne a lot of fruit that they're able to do this at 210 watt board power. It's very, very impressive. There is a somewhat minor fly in the ointment, and that is if you have an older machine. So I've set up a 10700K here, and I've done testing with the ARC B580 as well as the RX 7600. The RX 7600 is still outmatched and outclassed by the B580, to be clear, but the software overhead and the driver and the advanced features of the B580 don't work quite as well on the older CPU. And in games like Cyberpunk, as an example, but this is true on games that have a lot more CPU demand, you get into a situation, especially in this 10700K, where it seems like the graphics driver is competing a little bit with the game for overall performance. It's better than I expected, but it's still not fabulous. So it's not a silver bullet if you have an older CPU, and if you're looking at our general performance numbers, which were done on better, more modern CPUs, you may not get anywhere close to the same performance on an older CPU. Bottom line, modern games on an older CPU with a cutting edge GPU where they're really pulling out all the stops on the software side, the B580, can be not a fabulous experience. And it's still better than the RX 7600. The RX 7600, 8 gigs of VRAM, it's at the end of its life cycle. And AMD's got something loaded up in the queue, but not a good fit here either, even though it does suffer a little bit less than the B580 when we're talking about older CPUs and older platforms. That may be something to visit in another video, or something to look for specifically in other reviews. Is like, hey, what CPU do I have? Am I considering this for an upgrade? Has anybody done any testing specifically with that CPU? Hell, hit me up in the forum. Maybe we can put something together with your specific system and just see how it goes. Like, what's the performance look like? How does it actually work? As long as it's still generally better than competing cards, it's fine. And that's what I found with the RX 7600. It's still better than an RX 7600. It's just not better by as much of a margin when you're suffering with an older CPU platform, is what I'm trying to tell you. There's some nuance lost in that explanation, and some subtlety, and some detail, but bottom line. Now, benchmarks. Before we get into the benchmarks, I want to just tell you up front, I'm going to do something a little different here. Instead of going through 25 or 30 games that I play tested, because this is, you know, I want to say it's player 3 entering the game, but player 3 entered the game a while ago. But what I want to make sure that you understand is that the engineering team behind this GPU has different engineering goals than the other GPUs that are available. And so I wanted to cherry pick a couple of titles to start with and to start that conversation with 1080p. 1080p games at the highest preset. If we look at this, it's like, okay, Shadow of the Tomb Raider, 180 FPS versus 158 FPS of the 7600. Now, this isn't a bad start. The biggest detractor here is the 7600 is old news, and the 7600 was not amazing when it first came out. It was okay. But the price point, this is a much more aggressive price point a year later than the 7600. If we look at Baldur's Gate 3, 81 versus 84 FPS, 71, 68, depending on if you're using Vulkan or DirectX 11. This is a little bit of an impressive result, if for no other reason than when Intel first launched their Arc line of GPUs like the A770. DirectX 11 performance, maybe not amazing. But this is a really good result, all things considered. And then we look at something like Warhammer 40K. It's like 68, 64, 4340. Again, these are 1080p results, and it's like, well, okay, the card's going to be a little bit cheaper, but that's, last generation's card. Like, is AMD going to have a $250 price point? We know Nvidia is not. We'll talk about that too in a second, but okay, I mean, this is fine. But this is extremely misleading. This, taken in a vacuum, doesn't actually show how good this GPU can be. Well, let's take a look at Cyberpunk 2077. Now, Cyberpunk 2077 is a terrible game for a lot of reasons in terms of benchmarking and everything else, but doing our own run-through at the city center, where the performance is really not amazing, at 1080p with no RT, but on Ultra, so FSR quality frame gen on 196 FPS. This is very good, and this is the best visual fidelity in this particular game. FSR quality with frame gen off is still 129 versus 107 FPS. This is a pretty substantial uplift for a card coming in at this price point. XeSS quality with frame gen off, 127 FPS, and no upscaling with frame gen off is 99 FPS. I wouldn't have expected this big of a spread between FSR quality and frame gen versus no upscaling and frame gen off. 83 to 99 versus 167 to 196. At 196 FPS with FSR quality, the gameplay, the actual gameplay experience was very, very good. And keep in mind, this is 1080p. Now here's where things get really interesting. RT Ultra. Turning on ray tracing. Like, ray tracing is a thing? Yeah. Intel apparently needed to show everybody how it was done, I guess. Because this even beats the pants off Nvidia for the low-end cards for ray tracing. This is almost like a 4090 experience. Not really, that's a little hyperbolic at this price point. But yeah, 119 FPS. Now this is frame gen and FSR quality, but this was also very playable. Like, the gameplay experience with this is what I really wanted to drive home, and that's why I'm sort of doing the benchmarks a little different. Instead of going through 30 different games, the gameplay experience was very, very good. Shockingly good. FSR quality with frame gen off, we still managed 70 FPS and 72 FPS with XeSS quality and frame gen off. With everything off, it's 23 versus 40. That's still a doubling. It's double the performance, even in a worst case scenario. But how do you go from 40 FPS to 119? That is the level of software engineering that has gone into this. And in terms of real, actual gamer gameplay experience, that is shockingly good. Now, that is not to say that Cyberpunk 2077 did not have its weird quirks with this card, but that was down to Cyberpunk 2077. For one, constantly going through and changing the graphics settings could lead to game instability, and sometimes I would have to hold the key, I think it was like F1 or something when you start Cyberpunk, in order to get it to recover from a bad combination of graphic settings. But Cyberpunk was the only game, well, Cyberpunk and F1 2024 were the only games that I experienced any kind of driver weirdness. So, good job. Speaking of F1 2024, the spread here is also very, very impressive. And keep in mind, this is 1080p. We're looking at 1080p. 1080p is actually the least impressive of the results from the Arc B580, but this is still a very impressive result overall. I would not be as enthused with this card if the other graphics results or the other benchmark results sort of followed suit with this. But let's take a look at 1440p. 1440p, 93 versus 109, 71, 68, okay. Baldur's Gate 3, it's not dramatically better, but it's also not dramatically worse. And pretty much no game that I tested was notably worse except possibly Starfield. Cyberpunk at 1440p was a very playable 134 FPS. Now the thing that I want you to notice here is, wait a minute, 1080p, 1440p, this card doesn't scale resolutions the way that other cards do. If I've got a 4090 and I'm running at 500 FPS in Shadow of the Tomb Raider at 1080p, oh, it's going to perform really well in 4K. This card performs about the same, I mean, real world gameplay experience, not FPS numbers, at 1440p as it does at 1080p. So Intel, when they say, oh, this is a good card for 1440p, what they mean is that the numbers don't look as good at 1080p, but the 1440p numbers are amazing, and that's probably owing to the GPU architecture and the engineering choices that were made here. 130, 140 FPS at 1440p on the Canada track, wet, is very impressive on ultra-high graphics settings. Now what about RT Ultra on Cyberpunk 2077? 78 FPS. This is a very, very good result. I was also very surprised by the result from the 7600, 68 FPS. This is a huge improvement from AMD because with FSR quality and frame gen off, it can only manage 20 FPS. Subjectively, the gameplay experience on the 7600 with FSR quality and frame gen on, not as good as FSR quality frame gen on the new B580. The 3D Mark scores were overall pretty impressive, Time Spy as well, as were other productivity benchmarks, things like Blender and Geekbench, and the Puget Creator Suite. So this card can hold its own in creator workloads, at least versus cards that are 8 gig and a little constrained like the 7600. So yeah, maybe it would make sense to split out the actual raw benchmark results into its own video, but subjectively, my experience was better than I expected with this card by quite a margin. This is a solid card for doing 1440p gaming with AAA titles. I was shocked by that, but also just the gameplay experience. The card feels a little different than Nvidia and AMD cards, and this is owing when you run it with everything. Like if you just want to run the card with no upscaling, no XESS, it is not as impressive. So overall, the game benchmarks are pretty impressive. And yes, I've cherry-picked a few game benchmarks, but depending on what the game is, it's going to fall into one of those categories that mostly it performs better, or quite a bit better, and the regressions are minor to non-existent. There are a few bugs with XESS, but overall it's very good. But this card also plays nice in the FSR ecosystem, so yay FSR upscaling technologies, at least in the quirky, specific Cyberpunk scenario, which is atypical, but still worth talking about, in my opinion. Yeah, so let's ramble a little bit more about all that. So what's the bottom line? This is a firecracker of a card. The performance is incredibly impressive. Generally, it's a sweeping win, at least when we're talking to price to performance ratios, from both AMD, which I focused more on, and Nvidia. Nvidia is a different conversation. We'll talk about that. Nvidia has a different product strategy, but overall it is a shockingly impressive card. One, on the software side, with the technologies that the Intel team has managed to pull out of a hat in terms of lowering frame latency, PresentMon, like the engineering that has gone into that, this is a software team that has moved at an incredible pace. Second, Intel has priced this thing aggressively. I can't imagine the margins here are amazing, and I worry about that a little bit with Intel's board of directors and everything else that's going on at Intel. But it's a solid card, and whatever they've done on the software engineering side of things, it shows. It shows amazingly. This being a 12 gig card as an entry-level card is also amazing because, Nvidia consistently wants to give you as little VRAM as possible. Some have criticized that as planned obsolescence. I think there's a little bit of truth to that, meaning that the GPU is slower than you want before it's really like at the end of its lifetime. Like computationally it's fine, but it doesn't really it's not really able to run the latest AAA titles. Now, Nvidia, for their part, I think part of their business strategy, and mark my words, going into the 5000 series of GPUs, is to sell you less hardware because they think they're going to make it up in superior software. I don't think that's a valid, like, my personal opinion on it is I would rather have more hardware and let the software improve. That as a business strategy, selling you less hardware with better software is not something that I, as a consumer of that hardware, would want. Because if I've got the hardware and I can make up for it in software, then, let's go. But over the last 5 years, if you look at options from AMD and then later Intel, there is a little bit of truth to that, which sucks for AMD, but Intel is coming in fast with the software side, and apparently a very competent team able to move very quickly if they're able to crank out the kinds of things that we see, and to go from what we saw in the Arc launch, the Alchemist launch, the original Intel GPU launch, to where we are now in 2024. The other worry that Intel has is that they're the first out the gate. We know that new GPUs are coming from AMD in short order, and we know that new GPUs are coming from Nvidia in short order. What are their offerings going to look like? Nvidia, for their part, I think their approach is going to be more, less is more, which means that what Nvidia wants to sell you for $250, Nvidia knows that they're the premium brand. The thing that's $250 is going to be slower and worse, but the software may make up for that in Nvidia's mind. AMD is a bit of a wild card here. Has AMD learned lessons and moved their software team ahead? Like, have they done the needful in the reorganization? Like, what does AMD have on the software side? How aggressively is AMD going to price things? Maybe AMD's sweet spot is going to be that $300 to $500 graphics card. The 7900 XTX at the highest end is an amazing card. The weakest point is ray tracing, of course. And so what is AMD going to have for ray tracing for the $250 option if you're after the graphics fidelity? What's going to be the 12 gigabyte option? Is the 12 gigabyte VRAM option going to be their opening salvo, their opening, configuration for gamers? That's the question. But right now, today, if you had to buy a graphics card today, this is a firecracker of a card. It's shockingly good, and it's excellent in newer and even middle-aged systems. It's maybe not a good choice for older systems. It's definitely not a good choice if you can't enable resize bar or you don't have the BIOS options for it. Like, you're not going to have a good time using this as an upgrade for an ancient system. And even an older system will suffer in ways that you don't necessarily expect. But kvetching there, this is a really shockingly good card. Good job, Intel. Good job, Intel programming team. It's really shining through. And the hardware is pretty good, too. Nice. Competition. Yay! I'm One of this Level 1. I'm signing out. You can find me in the Level 1 forums. Let me know if I missed anything or you have any questions.